So protein absorption is very similar to carbohydrate absorption. And if we review, we know that proteins start chemical digestion in the stomach. And they do that through pepsin, which is the activated form of pepsinogen. And that pepsin breaks down the proteins into smaller polypeptides. So we can say that's pepsin here. Those polypeptides will go into the lumen of the small intestine, and there they will find enzymes from the pancreas called peptidases. And those pancreatic enzymes like trypsin, chymotrypsin, and carboxypeptidase will break down those polypeptides into smaller peptides. From there, they'll go to the brush border, where then they will be broken down into tripeptides, dipeptides, and amino acids. So don't forget, a tripeptide is amino acids, 3 of them, linked by a peptide bond. A dipeptide is 2 amino acids linked by a peptide bond, and then amino acid is on its own there. So those are the 3 ways that proteins are absorbed into the body. So if we have our small intestine cell, so this is where we're going to start here. So let's make our little cell here. Make it kind of big down here. Let's put a blood supply. Must have some place for it to enter the bloodstream, right? So there's our little blood supply. All right, up here we have microvilli, and that forms the brush border. So when the peptides get into contact with that brush border, then they come into contact there, and they are broken down into one of those 3 types of peptides: a tripeptide, a dipeptide, or an amino acid. So tripeptides and dipeptides enter the cell the same way. So I'm going to put those together here. And then amino acids enter a little differently. Okay, so amino acids are the easiest, right? Because they're going to be the smallest anyway, so think of it that way. So amino acids enter a lot like carbohydrate in that we use sodium to bring them in. So we know there's sodium out here in the lumen. So there's sodium there. And in the plasma membrane, we have a transporter that allows for sodium to come in with its gradient, and it will pull the amino acid with it. So again, the same as with the carbohydrate mechanism, we must have the sodium-potassium pump here on the basolateral membrane. Okay, so this pump is going to take this sodium and pump it into the blood while pumping out or back in potassium. Okay, and that's going to maintain the gradient for sodium. It's going to keep sodium flowing in up here at this transporter and bringing in amino acids with it. Tripeptides and dipeptides come in a little differently. So tripeptides and dipeptides are also facilitatedly diffused or whatever into the cell. So we have to build up a gradient. It doesn't follow sodium. Okay, it follows something else. And what it follows, if we have this transporter here, this transporter also transports sodium. But what it does, it's a an antiport, I guess is what you call that. So it brings in sodium here, and it pumps hydrogens out. So we're getting sodium in, and it's forcing hydrogens out. It's kind of like a trade between, with two positive ions there. This is called the sodium-hydrogen co-transport. Sodium-hydrogen co-transporter. And what it's going to do is it's going to create a gradient for hydrogen. So it's going to keep pumping out hydrogens out here, creating a gradient for hydrogen to go back into the cell. Once we have that hydrogen up here, or hydrogen out in the lumen there, then we have another transporter that brings the hydrogen back in, and with it, it pulls the tripeptides and the dipeptides. Okay, just a little bit different. So at the bottom here, of course, they can't stay in the cell. So down here, there is a transporter that allows for the entrance of all of these. So entrance of my amino acids and my di and tripeptides. Should make that blue, I guess. And once in the blood, of course, it's going to head towards the liver. Okay, so that's the whole process for proteins. So next we're going to look at lipids and how they are absorbed.